Hi, everyone. Nice to be back. Welcome back to the round 16 of our Crowdcast Q&A series. I love doing these. Always learn a lot. For those of you, this is your first time attending live, or for those of you listening on your podcast player or watching a replay on YouTube, I generally choose questions. I look at a combination of factors. I look at the top voted question. I also look at questions that I think I've never answered before. I also look at questions that I've had maybe several times by other people through various different sources, and so it's kind of a combination of everything. If I don't answer your question this time, chances are I may get back to it another time. I do archive all the questions and pull from archived questions as well. So you can also resubmit your question. I've noticed people have done that as well. Before we jump in, just remember that me answering these questions, my team and I, we do review of the scientific literature and, kind of come up with the best answer with the current state of evidence. So this is not medical advice. I'm not a medical doctor. So please, any information you get from these crowdcasts, if it's something that you're going to change, do some sort of change, run that by your physician. So with that said, I also do answer live questions in the chat as well. And I do rapid fire questions. So oftentimes I'll do a couple of deep dive answers in the beginning and then go on to do some rapid fire questions. The first question I'm going to answer, it's not a very long or in-depth question, but I've had it so many times that I thought I probably should go ahead and answer it. And the question was from Jennifer, and Jennifer asked, are there any studies showing the benefits of hot yoga? Are they comparable to the sauna? So the environment of hot yoga is, somewhat comparable to sauna. The core body temperature during hot yoga often exceeds 103 degrees Fahrenheit. And sessions can last up to an hour, sometimes over an hour. There really aren't any head-to-head comparisons looking at hot yoga versus the sauna. There have been studies showing that hot yoga improves a variety of biomarkers that sauna use has also been shown to improve. So cholesterol levels, arterial compliance, which is basically the ability of your arteries to respond well to stressful conditions. Anxiety, depression, those things, and stamina all have been shown to improve with hot yoga. And similarly with sauna use. It's difficult, of course, with hot sauna to uncouple the effects of the heat stress from the exercise. However, exercise itself causes heat stress, and sauna use has directly shown to mimic the effects of exercise in a head-to-head comparison. So I think that it is my opinion that doing hot yoga can result in similar effects as a hot sauna, like 179 degrees Fahrenheit, 20-minute, session. But, only future studies will really be able to elucidate that. And so, in the meantime, it's really just speculation based off of sort of the things I just mentioned. By the way, I love Bikram yoga. I love hot yoga. So the next question is sort of a really deep and broad overview of the current state of the scientific literature. And I've had this question many times. And the question this round was submitted by Dwight, and Dwight asked, what does the latest research on lion's mane show? And I've had this question in many different shapes and forms, but ultimately people want to know about lion's mane. So let's talk about it. Lion's mane is sort of the common name for a mushroom, Herculaneum erinaceus. It's a fungus that has been used in Eastern medicine, and there's been quite a few studies in rodents, so animal studies, which are preclinical, and there's been in vitro studies, which are studies done with cells in culture. It's very difficult to translate, what those findings mean in humans, but there have been a handful of clinical studies as well. So we'll talk about some of that. Probably one of the biggest claims with lion's mane is the effects on the brain and in preventing dementia. There's only 2 human studies that have looked at lion's mane for preventing cognitive decline. The first study was a double-blind, placebo-controlled trial in individuals that were 50 to 80 years old, and they had been diagnosed with mild cognitive impairment. So lion's mane improved their cognitive function scale, like the scale that's done compared to placebo after 8 weeks. However, after 4 weeks of stopping the lion's mane, so after cessation of the lion's mane extract, the cognitive, improvements went back. They sort of regressed, and so cognition went back to baseline levels. So the lion's mane, the effect on cognition from the lion's mane required a constant, intake of it. It wasn't something that seemed to change the brain wiring long term. People taking the placebo also saw a small and statistically significant improvement in cognition, which could imply that some of the improved cognition was from the placebo effect, which is a very real and strong effect. So it's hard to say that, whether or not, this is a new clinical study. Another clinical study showed an improvement in cognition, but that clinical study also showed an improvement with placebo. So the 2 clinical studies, both of them showed an improvement in cognition. The first study, placebo did not show improvement, and the second study, the placebo also showed cognitive improvement. So it's hard to tell, whether or not there's really a meaningful effect with lion's mane on cognition. There's been some animal studies showing that it improves cognition, showing that it prevents neuronal damage, all sorts of effects on the brain. But these animal studies, the doses are just, it's not really comparable to something that would, be taken by a person. So, I really can't say, yeah, lion's mane is going to improve your cognition, because it's really kind of poor quality clinical data at this point. There's been some studies looking at anxiety and depression in animals, and animal studies have shown that lion's mane can improve depressive-like symptoms that are induced in animals, and comparable to animals, basically given SSRIs. It seemed to increase norepinephrine, it seemed to increase dopamine and serotonin, as well as anti-inflammatory compounds. Again, the animal studies, the doses, are just incredibly high and not really translatable to humans. There was one study done in humans. It was placebo-controlled, showing that lion's mane improved subjective measures of anxiety and depression in menopausal women after 4 weeks of supplementation. So, but it's unclear because these were subjective, so it wasn't an objective measurement, and so it's really unclear whether or not there's any effect on anxiety or depression. Nervous system injuries, recovering from that, animal studies have shown, again, that it can improve, but there's no human studies. gastrointestinal ulcers. There's some effects, benefits in mice. There's one human study that did show lion's mane improved symptoms of ulcerative colitis better than placebo, but there was no effect on Crohn's disease. So for whatever reason, this seemed to be specific for ulcerative colitis. Heart disease risk. There's a variety of animal studies showing that it improves lipid profiles, but there's just no human data, so it's hard to know. Same for type 2 diabetes. It improves glucose regulation in animal studies, no human data. And inflammatory mediators and the effects on inflammation and the immune system. There are, again, many animal studies, but no real human studies. However, it is known that beta-glucans, which are a component of mushrooms, are fermented by the microbiome in the gut, and this fermentation results in the production of signaling molecules known as short-chain fatty acids. There's a variety of them, butyrate, propionate, acetate, to name a few, and those signaling molecules go on to have an effect on the immune system. So it's quite possible that, just because we know this mechanism and we know that beta-glucans have been shown in human studies to affect the immune system, that, it's possible there is an effect on the immune system, even though there hasn't been studies looking directly at lion's mane and the immune system. In general, I think that lion's mane, it's just, I'm not necessarily convinced it's bad for you. I haven't really seen, data showing it's bad, although it is with mushrooms. The problem with mushrooms is that mushrooms do take up a lot of ions and metals. And so the source of the mushroom is important. And if it's really not a pure source, you can run into the problem where you're potentially, taking in heavy metals, for example, and then in which case you could potentially cause harm. So, take it with a grain of salt. The lion's mane, research is really, really in its infancy, at least in terms of human studies. So the next question, I learned a tremendous amount from, because I knew nothing going into this before. And this question was from Matthew, and Matthew wanted to know about my thoughts on whole fruit coffee extract. There's been a lot of recommendations in the popular blogosphere and media that whole fruit coffee extract, it has a beneficial effect on general health. And so the question is, is there science to back that up? So we're going to do a little bit of a deep dive on that and talk about some of the conclusions. So the background, really, for people that aren't familiar, I wasn't really familiar, but whole fruit coffee extract is made from fruit from the coffee plant, and the fruit is red, but the coffee beans are green. So during the roasting process to make coffee, the green beans turn brown. So there's been a lot of talk on the internet on the health benefits of this whole fruit coffee extract and green coffee bean extract before the roasting process. So there seems to be a lot of benefits, and we'll talk about those, that are very, very similar from the green coffee bean extract versus actually just coffee intake. So there's been some studies on weight loss. Animal and human studies have shown that green coffee extract can improve weight loss. In an animal study, mice given green coffee extract had increased fatty acid oxidation and reduced visceral fat, the fat that lines your organs, particularly in the midsection. It's the most dangerous type of fat. The bioactive components in coffee, like caffeic acid or chlorogenic acid, have been shown to improve weight loss, lipid metabolism, and obesity-related hormones in mice. And this was actually from just roasted. These are also found in roasted coffee or just regular, taking in regular coffee. There was the clinical study where green coffee extract was used. Actually, there's 3 clinical studies where it caused an average weight loss of 5.4 pounds more than placebo. So it was significantly more than placebo in the green coffee extract. But coffee has also shown a similar effect. People drinking coffee have also shown to lose significant amount of weight as well. So, hard to uncouple whether or not you can achieve the benefits from the green coffee extract from just drinking coffee or taking in some of the active compounds, which we'll talk a little bit more in detail in a minute, that are found in coffee. Blood glucose regulation, green coffee extract has been shown to improve blood glucose levels. So in one clinical study, supplementation with green coffee extract for 40 days resulted in a quite significant drop in postprandial blood glucose levels. So went from 145 milligrams per deciliter to 133 milligrams per deciliter. In addition, the participants also lost an average of 3 pounds of weight, and the participants were not asked to change their diet or exercise routine. Coffee has also been shown to have a beneficial effect on blood glucose because there's been several studies showing that coffee consumption can be protective against developing type 2 diabetes in a dose-dependent manner. However, many of those studies have been observational studies, which of course are difficult to establish causation without an actual placebo control. Cholesterol, there's been some positive effects of green coffee extract on lowering total cholesterol, on LDL cholesterol, and also on increasing HDL cholesterol. So that I would say is the biggest difference between green coffee extract and regular coffee. There's been an interesting study. In fact, there was one study, and I talked about this in a previous crowdcast, where unfiltered coffee was shown to actually it was shown to increase total cholesterol, LDL cholesterol, and triglycerides in a dose-dependent manner, but it was only unfiltered coffee and not filtered coffee. So unfiltered coffee like you would do in, for example, a French press. The compound that seems to be one of the most bioactive compounds in both green coffee extract and regular coffee, roasted coffee, is chlorogenic acid. In a randomized placebo-controlled trial, chlorogenic acid significantly lowered systolic and diastolic blood pressure compared to placebo, which was quite interesting. In another study, the chlorogenic acid from instant coffee, so people taking instant coffee for 12 weeks, actually they were taking the instant coffee plus they had an extra dose of the chlorogenic acid. It caused them to lose on average 12 pounds and had a 3.6% decrease in body fat compared to the control group, who lost an average of 3.7 pounds and only lost 0.7% body fat. So that's a pretty interesting study in terms of weight loss and body fat. But the chlorogenic acid content is higher in the green coffee bean extract. So the roasting process itself, you experience losses in the chlorogenic acid. So it's thought that because the coffee fruit extract, the green coffee bean extract, has much higher levels of this bioactive compound, the chlorogenic acid, that perhaps you could experience more benefits from taking in the green coffee extract. So there's been one study comparing the commercial green coffee beans and compared to roasted extracts, and looking at chlorogenic acid content. The chlorogenic acid content was found to be anywhere between 61 to 86 milligrams per gram in the green coffee beans, whereas roasting it reduced the chlorogenic acid levels by nearly 50%. So there's about a 50% loss. The study also found that chlorogenic acid levels in roasted coffee beans varied according to pH. So the lower the pH, so the more acidic the coffee, the higher the chlorogenic acid concentration, which is unfortunate for me because I hate acidic tasting coffee. And it seems as though the acidic tasting coffee actually might be the most beneficial because it has a much higher concentration of chlorogenic acid in it, which was good for me to learn. Perhaps I can maybe force it to be an acquired taste. There is, I do want to mention this one study where many, it's sort of like an echo chamber in the blogosphere, where you see people citing it time and time again, where there was a nootropic effect was found from the coffee fruit extract, and this was something that, I mean, it's just all over the blogosphere, where you get health, quote unquote, health gurus talking about it. And it really all stems from a very misleading industry funded study, where whole coffee fruit concentrate powder was shown to increase brain derived neurotrophic factors, BDNF, which BDNF is a growth factor found in the brain that's involved with growing new neurons. It's involved with neuroplasticity, which plays a role in cognition and depression. And the study found that BDNF levels increased by 143% with the green coffee bean extract, and that basically the chlorogenic acid did not do it, and the caffeine didn't do it. The problem is the study was severely underpowered, and so at first glance you read it and you go, oh, this whole coffee fruit extract is amazing. There were only 5 people in each group. In the green coffee bean extract, the caffeine, and the chlorogenic acid, they all showed increases in BDNF levels. But the increase was not statistically significant in the other groups. And it's absolutely almost a sure thing that if there were more people in each of these groups, there would have been statistical significance in the other groups. And so this was, again, an industry-funded study using this commercial patented whole coffee fruit concentrate powder. It was very, very, very concentrated. And so what you can do is you can find a group of people, like a sample of, people where you say, okay, we're only going to have 5 people. And because that coffee fruit was so concentrated, you'll find statistical significance in those 5 people. But if you were to increase it to 10, the statistical significance would be the same. You would find it in the other groups, and therefore you'd say, oh, well, there's no real difference between all these things. But because you limited the sample size to a very, very small group, you're going to see a more robust effect in fewer people than you would otherwise. And so it's a really anyone, if you look at any, if you ask any biostatistician, like anyone that's an expert in biostatistics, they'll tell you that this is pretty much, BS. It's a manipulation of the data. It's a way to figure out, like, how to see a robust effect in a very small sample size. So I would say that study is really not a well done study, and unfortunately, it's proliferated in the blogosphere. So take it with a big grain of salt. And that's pretty much my summary on the green coffee extract. Okay. I'm not seeing any relevant questions in the chat here. So I'm going to move on to the next question, which is one of the top voted questions. And this question was from Sarah. And Sarah asked, are there times statins could be contraindicated for a person with ApoE3/4, or is a statin important to take for ApoE3/4 with cholesterol over 200 LDL, with a LDL over 200, but low triglycerides and high HDL, in order to reduce or prevent cognitive decline? So just to kind of mention here, I am in no way can give any medical advice on statins, or whether or not a person should take statins or not. That is something that needs to be discussed with your physician. I can speak a little bit about what published scientific data sort of, what the information, where that information is at right now. But that's really it. And, from there, you really have to run and take any information, maybe some of the information you may find today, run it by your physician. So just for a background, ApoE, the ApoE protein, it is in what are called chylomicrons. And so those are intermediate density lipoproteins that then can form low density lipoproteins, LDL, and also high density lipoproteins, or HDL. There are three major types of ApoE proteins that are encoded by three major alleles in the ApoE gene. And those are called ApoE2, ApoE3, ApoE4. The most common allele is ApoE3. More than half of the general population has 2 copies of the ApoE3. Compared to people with ApoE3, the next most common one, common found one, is the ApoE4 allele. That's one of those alleles is found in about anywhere between 15 to 25% of the population. And it is having one ApoE allele. Having 2 ApoE alleles is much more rare, but also happens. But having one of those alleles is associated with much higher plasma levels of total cholesterol, and also higher levels of LDL cholesterol. And people with an ApoE4 allele do have a much higher risk of coronary artery disease. And the reason for the higher plasma levels of total cholesterol and LDL cholesterol are thought to arise because the ApoE4 protein found in the LDL cholesterol does not recycle the cholesterol, the lipoprotein containing the cholesterol, back to the liver quite as well. So cholesterol, your lipoproteins are transporting all these cholesterol and fatty acids and other things to various tissues, and after that, the lipoproteins bring the cholesterol, etc., back to the liver, where they're taken up into the liver, and so they only stay in the circulation for a transient amount of time. However, the ApoE4 protein found in the lipoprotein does not do that as well. It does not recycle it as well. And so at any given time, people with an ApoE4 allele have higher circulating levels of LDL cholesterol and total cholesterol. From a cardiovascular perspective, if you look at the American College of Cardiology, which looks at age and blood pressure, cholesterol levels, diabetes, gender, race, medications, things like that. Physicians, based on that, most would recommend a statin for someone over having cholesterol over 190, regardless of ApoE status or regardless of triglyceride levels or anything like that. So, again, very important to run this by your physician. But the question really was talking about cognitive decline. And, there's been a variety of studies looking at statin use and cognitive decline, and also studies looking at, cholesterol and cognitive decline. So blood flow to the brain is extremely important for cognitive function. And when you start to get, plaques that build up in the arteries, that can obstruct the blood flow to the brain and subsequently can result in, a deterioration and cognitive decline. So, because there's so many factors in the plaque buildup, but one of those is total cholesterol, LDL cholesterol. Higher levels of that can contribute. As we've talked about many times in these crowdcasts, the size of the LDL particle contributes significantly to that, with the small, dense LDL particle size being the most atherogenic because it appears to stick to arterial walls much better than large, buoyant LDL particles. And so particle size is a very important thing to discuss with a primary care physician, and measuring the LDL particle size when it comes to looking at atherogenic risk with looking at LDL levels. But there's been a lot of really interesting data kind of shifting to statins, looking at statins, and there's different types of statins. There's lipophilic statins and there's hydrophilic statins. And the lipophilic statins, which are fat soluble, there have been studies, in fact, FDA databases have found that neurological disease has been reported more often in individuals that have taken a lipophilic statin. And it's thought that's because lipophilic statins can cross the blood-brain barrier. So lipophilic statins include atorvastatin, lovastatin, simvastatin, and some others. There have been some reports that have suggested a correlation between statin use and Parkinson's disease, where people taking statins have a higher risk of Parkinson's disease. There have been some previous studies showing the opposite, but they didn't take into consideration confounding factors like hyperlipidemia. And hyperlipidemia, believe it or not, actually seems to protect against Parkinson's disease. And when data is corrected for hyperlipidemia, the protective effect goes away, and actually, so statin use is associated with an increased risk of Parkinson's disease. And it's interesting because there's a very important mitochondrial component in Parkinson's disease. Mitochondrial dysfunction has been shown to causally play a role in the degeneration of dopaminergic neurons in the substantia nigra, the part of the brain that does play a role in motor control. And the reason I'm mentioning this is because statins do many things. So one of the primary reasons statins are used to lower total cholesterol is because they block the production of HMG-CoA, which is an enzyme that's involved in production of cholesterol. But statins also block the production of something called mevalonate, which is a precursor to coenzyme Q10. Which is a fat-soluble substance that's found inside the mitochondria, and it's critical for cellular respiration. It's critical to make energy, and blocking the production of that pathway, essentially can cause mitochondrial dysfunction. And so there have been. It's thought that this mitochondrial dysfunction may also play a role in why several people that take statins also can have experienced muscle wasting, although there's also a large genetic component to that risk as well. So coenzyme Q10, there's been many physicians do recommend when they prescribe statins, they also recommend taking coenzyme Q10 as well. Particularly ubiquinol is the reduced form of CoQ10, which is much more bioavailable than ubiquinone. But really, from kind of going back to the cognitive perspective, it is important, again, from, there is association between, the cardiovascular risks and cognitive decline, such that, a more atherogenic profile can obstruct blood flow, and that can affect cognition. But there also may be some risks with particular types of lipophilic statins that should be discussed with a physician if someone is deciding whether or not to go on statins. So again, that's kind of just an overview of the literature, with no actual recommendations. So people in the chat are asking about just touching on some genetic risk factors that have been identified for a more severe COVID-19. There's been a variety of them, actually, and some of those risk factors appear to affect the initial, what's called interferon response, which is really critical for, it's sort of like the conductor in a symphony, where you're coordinating the initial immune response to a pathogen, in this case, the pathogen being the SARS-CoV-2 virus. And some people seem to have a really blunted interferon response, which makes them much more susceptible to this virus, because that interferon response is so key for having your immune system activated in the right way to basically, help clear out this virus. And without that response, the virus kind of can replicate and go replicate unhindered, basically, and can really lead to more severe effects. There's been a variety of other genetic risk factors that have also been identified as well, and sort of trying to keep up with that literature. I find it's very interesting, why some people, seem to have a very, very severe response, and that are otherwise healthy with no other pre-existing conditions. They perhaps are even, physically active and young, and so some genetic risk factors are being investigated for that. So I'm going to move on to one of the next top voted questions. And this question was submitted by, I don't know how to pronounce it, Mako or Mako. And Mako says, you've mentioned that you use a continuous glucose monitor and avoid foods that cause glucose levels to shoot up. I'd love to hear you discuss why you aim to keep blood glucose levels low. For example, is the goal to avoid the brief spike in glucose? If so, what's wrong with the transient spike after eating? Or does avoiding the spikes also cause lower glucose longer term? If so, what's the benefit of that? So I have been wearing for the last, is it 3 years now, 2.5? It's been quite a while, maybe 2.5 years. I've been wearing a continuous glucose monitor, and I've certainly learned quite a bit from wearing my continuous glucose monitor. I do aim to have, a lower postprandial glucose spike, so, meaning the response to the meals that I take in. And generally, I kind of like to keep it. I mean, I get obsessive sometimes, and I want it like, to barely go above 100 and milligrams per deciliter. But I also allow cheats as well. But typically the number I aim for is below 120. And the real reason for that is really kind of, it's grounded in a couple of things. One is something that was touched on in part of this question, and that is, does avoiding those transient spikes lead to benefits long term? And the answer to that is yes. So if you look at long-term biomarkers of long-term, blood glucose levels, which would be HbA1c, which is a glycated hemoglobin, the more often you have higher levels of blood glucose spikes, the more chances you have of glycation to occur on the hemoglobin, right? So you will have higher levels of that biomarker, and so I do aim to keep that my HbA1c levels as low as I possibly can. Anytime you have a blood glucose spike, the glycation, there's something that can form called advanced glycation end products. And these advanced glycation end products, or AGEs, AGES as they're kind of referred to for short, they damage proteins and lipids. They they can lead to like cross-linking in proteins, and basically can make things become sort of dysfunctional over time. And so avoiding any possible exposure to having those things form is a good thing for aging. But the other reason I really try to avoid having a transient spike in blood glucose levels frequently, I mean on a day-to-day basis, like I said, sometimes I'll eat some a sushi with some brown rice, or brown rice will raise my blood glucose levels like no matter what. But the reason I try to do it on a day-to-day basis is every time you increase your blood glucose levels, you are activating a molecular pathway called the AKT pathway. And this AKT pathway activation it inhibits a variety of genes that are really important for dealing with stress. So it inhibits, in particular, one called the FOXO3 gene, which is a master regulator of, so FOXO3 activates genes that are anti-inflammatory. It activates genes that are antioxidant. It activates genes to increase stem cell production. It activates genes for autophagy. It activates genes for DNA repair mechanisms. I mean, pretty much everything that you want activated. And if you that whole pathway is shut off when glucose levels go up, when AKT levels increase, when are activated, which happens with glucose. So just looking at the molecular level and knowing what I know about, like these pathways being activated, and even though your blood glucose levels can rise transiently, in other words, let's say your levels go up to 150, 160, and they, an hour later, for about an hour, let's say, and then they start to go down, right? So for about an hour period of time, you have elevated blood glucose levels, depending on how good your blood glucose regulation is. Now, some people that are sedentary, I mean, that spike is much less transient because it takes people a lot longer to clear the glucose from, their blood system, because they're not physically active, which increases the amount of glucose transporters in muscle tissue, which are taking, the glucose into your muscle, where it plays sort of an anabolic role. That, even though that can be a transient thing, say, for example, in myself, the AKT activation, those effects last much longer. So even though you're only transiently spiking your blood glucose levels for maybe 1 to 2 hours, let's say, your AKT activation, there's a much longer effect. So it's sort of like this, this delayed response that happens. And so personally, I'd rather not just have my AKT levels kind of suppressed and my FOXO3 activated during a fasting period, which happens, overnight, but I want it to be, as active as I can throughout the day. So I sort of aim for that, keeping the glucose levels lower, and I do that, so I drink a smoothie in the morning, and my smoothie these days consists of kale, avocado. Kale is not, something that really spikes my blood glucose levels, or in general, most people. And avocados also don't spike my blood glucose levels. I also add in some blueberries, and the blueberries plus, the kale and the avocado, and then I add in some egg white protein powder and some collagen powder, hydrolyzed collagen powder. And I drink a large, anywhere between a 12 to 16 fluid ounce serving of that. And my blood glucose levels shoot up to maybe 105. And it's very, very transient, actually. And I usually exercise and they go, right back down to their 80s, into the 80s. And so, I don't really consider that a big spike in my blood glucose levels. Most of the meals I eat consist of protein and vegetables, whether they're raw vegetables or cooked vegetables. And so oftentimes, my blood glucose levels postprandial won't go, over 100. There are certain things that will raise, certain vegetables that will raise them higher, like butternut squash, for example, or tomatoes. They'll raise my blood glucose levels higher. But generally speaking, that's sort of why I like to keep my blood glucose levels consistently lower. I see questions in the live chat. Corey's asking about cooked and cooled rice, and if there's a difference between my blood glucose spike. I have not noticed any difference. In fact, white rice is like insane in terms of like, you can just eat a little bit of it, and the amount that it raises my blood glucose levels is just completely unjustifiable, because I'll still be hungry. I'm not even satiated. So I avoid white rice like the plague. And now I mentioned sometimes, like, I've even now really kind of like tried to avoid even brown rice, because brown rice also really raises my blood glucose levels like just too high. And I just don't find it to be very worth worth it, in my opinion. So so I really just, rice is one of those things where it's like, it just raises my blood glucose levels just too high. And it's just like, I'm not getting a bunch of micronutrients. In fact, another question I was going to get to in a minute, from Melissa Bailey about gluten, suggests that rice actually, is a very significant source for arsenic exposure for people. So we will talk about that in a minute. But yeah, so that's my thoughts on rice. Why don't I get into the? I'm gonna get into the rice question in just a minute. But another question that was also top voted was from Janice, and Janice was saying that her genetic reports show that she's got a variety of SNPs that indicate that a high fat diet would be disadvantageous for her in terms of cardiovascular risks and more. And but that ketogenic diets have been shown to, at least preliminary evidence has shown to be beneficial for Alzheimer's disease, and people with ApoE4 have an increased risk for Alzheimer's disease. And so Janice is wondering if an overnight fast of, let's say, 16 hours, which does, for most people, kick them into ketosis, is that, something that would be sort of equivalent to doing a ketogenic diet in terms of being protective on the brain. And so just to kind of start with this, to answer this question of being in ketosis, so there's differences here when you're talking about a ketogenic diet and being in, fasting induced ketosis, right? For one, when you're in fasting induced ketosis, you're immobilizing fatty acids from adipose tissue, and those fatty acids are used to produce ketone bodies. And there's beneficial effects from ketone bodies themselves in terms of, for example, beta hydroxybutyrate, which is the major circulating ketone body, has been shown quite nicely by Dr. Eric Verdin and others that it can activate genes involved, anti-inflammatory genes and antioxidant genes, and protect mitochondria. It's very, very nicely has been shown to protect mitochondria from damaging free radicals, which they produce because of the activation of these antioxidant genes. Beta hydroxybutyrate is also a very energetically favorable source of energy for mitochondria, because it can be converted into acetyl-CoA using less energy than glucose can. And so it's energetically favorable in that sense, because it can, it requires less energy to make energy, basically. It also, because you are producing, ketone bodies in the brain, and neurons can then take up that beta hydroxybutyrate, it allows something called glucose sparing to occur. And glucose sparing is when, the glucose doesn't necessarily have to be immediately used as an energy source, because you've got this alternative energy source. And so the glucose is then shunted into another biochemical pathway known as the pentose phosphate pathway, which makes something called NADPH, which is a precursor for the production of glutathione, which is the brain's major antioxidant. And so it's also, at least in several animal studies, it's been shown that, having glucose sparing and the production of glutathione can help protect against oxidative stress in the brain, because you're making more of the, of the brain's antioxidant, glutathione, the brain's major antioxidant system. And so that's able to then, basically ameliorate some of the oxidative stress that's produced in the brain from just normal brain aging, of course, and from other things as well. But so that, is a benefit from the being in ketosis, whether the ketosis is from fasting induced or ketogenic, a dietary induced ketogenic diet. Obviously, with the ketogenic diet, a person would have at any given time would have more or higher circulating levels of ketone bodies like beta hydroxybutyrate, because you're not just in ketosis overnight. You're theoretically should be in it, all day. But there's differences as well. I mean, when you are eating fat, you're giving yourself a constant sort of a constant source of fatty acids. And so you're not activating the same autophagy pathways and stress response pathways in that sense, right? So there's a difference there. Personally, there are ways to do a ketogenic diet without, having to take in nothing but saturated fat and butter and pork and dairy. There are other sorts of fatty acids like monounsaturated fatty acids from avocados, from nuts, from olives, olive oil. There are healthy polyunsaturated fatty acids like omega-3s from, dietary sources like salmon, from nuts as well. And, so there's ways to perhaps get a higher fat intake without having to take in so much saturated fat, for people that may have a variety of SNPs that basically may predispose them to a more adverse cardiovascular profile from a constant source of saturated fat. So there's a book that was recommended to me from my friend Dr. Eric Verdin, who has studied the effects of ketogenic diet in a variety of animal models, and he's been on the podcast previously, called The Ketotarian. And I got the book, I didn't read it, but I did look at some of the recipes in there, and I really liked some of the recipes, where there's a lot of alternative sources for doing a ketogenic like diet with salmon and avocados and nuts and olive oil. And so that's something that I'm actually interested in trying in the near future. So you guys can definitely follow along. I will be talking about it when I actually embark on that. So that's also something to keep in mind. So in the chat, Maxim is asking about beta hydroxybutyrate supplementation. So taking an exogenous beta hydroxybutyrate ketone ester, which have been shown to be much more powerful than taking in the beta hydroxybutyrate salts, is a possibility as well. I think there's limited evidence on exogenous beta hydroxybutyrate supplementation, but there seems to be some preliminary evidence that may help with cognitive function temporarily. Keep in mind the effects of exogenous ketone esters are very transient. 2 hours probably maximum. So, that's also something to keep in mind. That's extremely transient. So you're talking about probably doing the following the time restricted eating schedule where you are actually getting when you're inducing ketosis through a fasted state because you are fasting for a longer period. Most people, it really depends on a person's food intake and their lifestyle pattern. So people that are physically active can go into ketosis much quicker than people that are sedentary, and because they can deplete some of their glycogen stores. Also people that are more fat adapted in the sense where their body is used to oxidizing fatty acids and producing ketone bodies. People that are more adapted to that can more easily shift into ketosis. So those are also, there certainly is variation in terms of an overnight fast, and some people can get into ketosis quite early, after just 10 hours of an overnight fast, perhaps even less than that, depending on the person's how much food they've taken in and how physically active they've been. But other people can, it can take them quite long, maybe even 13, 14 hours. So there is definitely a lot of individual variation in terms of how quickly a person can get into ketosis. So the next question was from Melissa Bailey, and Melissa asked, she says, you've mentioned that you follow a paleo type diet and avoid gluten. What evidence leads you to the decision to minimize or eliminate gluten containing and other whole grains? All right, so mostly I have avoided whole grains. I'm going to say mostly because I actually don't avoid them all the way. Mostly due to the glucose spike. I've noticed that if I eat oatmeal, if I eat whole grains in general, like bread, that transiently spikes my blood glucose. And as I just mentioned and answered another question, I sort of like to minimize that transient spike. And so for that reason, I've sort of shifted more to a more paleo type of diet. I don't always do that. So I have noticed if I eat sprouted, so a whole grain sprouted bread, Food for Life is the brand I use. I like their Ezekiel sprouted flaxseed bread. Let's say I were to make, particularly if I eat the bread with some protein, I really don't get the transient spike as much. So maybe perhaps if I have, let's say I have a turkey sandwich and I use the sprouted bread and I have 2 slices of it. Let's say I have a whole piece of it. I mean, a whole sandwich. My blood glucose spike, may go up to like 111. So it's really not that bad at all. And so for that reason, I do mix in some of the Food for Life sprouted bread. Non-sprouted bread, I've noticed it does increase my blood glucose levels much higher than that. So I tend to avoid that type of bread. So a lot of people, they avoid whole grains or gluten because of this gluten thing, where basically, gluten's like the bad guy. In fact, about 25% of Americans report following a gluten-free diet, despite the fact that less than 1% of the population actually has celiac disease. And so celiac is caused by a variety of, there's variations in genes that basically mount an immune response when the gut is exposed to a group of proteins that are found in wheat, oats, maybe not as much oats, but barley and rye, called gluten. And so basically there is something that's in gluten called zonulin. And your gut cells have tight junctions between the epithelial cells, and zonulin can very transiently sort of open those tight junctions up. And the one of the functions of the tight junctions, or the gut epithelial cells and the tight junctions that are keeping them together, is that it's separating the immune cells that are found in the gut from the food. And so people that don't have celiac disease or don't have actually gut issues in general, the opening of it's like so quick and then closes back up. So it's really, you're not getting a really bad immune response, generally speaking. The exception is people that do have gluten sensitivity. And in fact, I think even people that have inflammatory bowel disease, Crohn's disease, things like that, because their tight junctions are already sort of dysfunctional. You're talking about, exacerbating inflammatory response in the gut, because the zonulin can open that up, and the immune cells then can basically become reactive and cause more inflammation. And so, that's, I think there's a valid explanation for why many individuals with gut problems should avoid gluten. For that reason, it could, exacerbate their inflammation in their gut. But with that said, there have been studies showing that people, in their minds, they have it that, gluten's so bad because it's been painted so bad in the blogosphere. And that there's actually been a study that have looked at people that were given, they thought they were given bread with gluten. They weren't told, so there was two groups of people, and one group got the gluten and the other group got bread without gluten. And the people that didn't have gluten reported having all sorts of bloating and discomfort and inflammation and all this stuff, but they had no gluten. And so it's called a nocebo effect, where basically you think something bad's going to happen, so you basically can induce this bad feeling. So that is something also that is a very real thing, like the placebo effect, where people think something good's going to happen. And so they, like anxiety and thinking something bad's going to happen negatively affects the gut. Anxiety and stress hormones and things like that have also been shown to break the tight junctions apart and to activate immune cells in the gut. And so that in itself is going to have a negative effect on the gut. And that appears to be what happened. And it's really interesting, because if you actually look at the scientific literature, people eating whole grains, they actually have been shown to. So there's been a variety of studies that have looked at whole grains, refined grains, and fiber intake, and all-cause mortality. And it's actually been shown that that people that take, for every 4.7 grams of fiber intake from whole grains, that there was a 17% reduction in all-cause mortality. And this was not the case for refined grains, which were positively associated with inflammation. So if whole grains were so bad, if they were so bad for you, you wouldn't see this dose-dependent effect on a reduction of all-cause mortality. There was another study that looked at about, and this was a big study, that study I just mentioned was about 11,000 people. There's another study, 8,000 women that had type 2 diabetes. They had between a 16 to 31% lower all-cause mortality if they took in, more whole grains. So they're, again, low all-cause mortality is going down with more intake of whole grains. There's also been, other studies that have looked at blood biomarkers of inflammation, including C-reactive protein, fibrinogen, and others upon whole grain intake. And so after adjusting for other dietary and lifestyle risk factors, whole grain intake was associated with lower biomarkers of inflammation, lower biomarkers, C-reactive protein and fibrinogen, but also the refined grains were not associated with those lower intakes. So I'm saying this, again, I mentioned that I don't take in whole grains because of the glucose, the transient glucose intake, right? And I'm telling you this because I'm sort of just playing devil's advocate here, and I'm saying, look, you do get a lot of people in the blogosphere saying that whole grains are like so bad for you. But the reality is that even though there's tons of confounding factors with observational studies, and you might say, well, people taking in whole grains also exercise more and all that. Of course, the data corrects for that. And there's definitely a healthy, a user bias there. The reality is, if whole grains were so bad for you, like, they should negate that healthy bias, right? They should be causing inflammation. And they're not. They're associated with lower biomarkers of inflammation. They're associated with lower all-cause mortality in a dose-dependent manner. So, I mean, the evidence does suggest that maybe whole grains aren't so bad. But again, I've got my nuance there where I'm like, well, maybe they're not so bad, but let's say you can take in just as much fiber from other sources of food, like greens, like vegetables. So, so then you don't get the zonulin at all. So then the question is, well, would that be even better? And we don't know. There hasn't been a head-to-head comparison of that, right? But I think the reality is that when you take away whole grains, a couple of things happen. One, for the worst possible scenario is people actually replace that with refined grains, and that's absolutely bad, right? Another scenario is you take away the whole grains and people aren't getting as much fiber, and fiber is actually extremely important for overall health, and so that might be also why people are, why there's a lower all-cause mortality dose dependent when taking in whole grains, is because you're getting that fiber. And so people, let's say they're not getting that fiber when they take away the whole grains, they're not replacing it with, let's say, vegetables. So that could have a negative outcome if that you take away that fiber source and don't replace it, right? And the other thing is that people taking away the whole grains then replace it with a non-gluten source, let's say rice, and then you get what I mentioned earlier. You're getting the whole possibility of arsenic exposure. And there have been studies that have found people that follow gluten-free diets have much higher levels of arsenic in their blood. And there have been a variety of studies showing that rice accumulates arsenic and also mercury, but really arsenic, and it's from fertilizers, from the soil, from water. And so, that is something to consider. And I've seen people in the chat asking about types of rice with lower arsenic, and there are certain types of rice, some in California that have lower arsenic, but not all California brands. In fact, I use a third-party testing service called Consumer Lab, and they've done a whole report on rice and arsenic, and they've measured arsenic levels in a variety of different rice brands and rice types, and they have published that report, on their. Well, they have. It's you have to pay a subscription fee to access that data, but it's like $30 or something like that, and you get a variety of other. They do third-party testing on like turmeric, which is also heavily contaminated with lead chromiate, which is bright sort of yellow orange color, and so a variety of turmeric powders from Bangladesh and some parts of India are often contaminated with lead chromiate because it's cheaper and it's got this brilliant, pretty color, and so it looks nice and healthy, but actually it's very bad. So Consumer Lab's done testing on that, as well as cocoa powders, which are contaminated with cadmium and also arsenic. And so they've done a lot of testing on a variety of brands and sort of published the data that they found. And so for those reasons, I really like that site. I have no affiliation with them, by the way. So that's like, if you are someone that wants to eat rice, then I would definitely recommend looking at data published on brands and varieties, types of rice that have less arsenic contamination in them. Okay, so I'm going to move on to some rapid fire questions. Scott asks, he saw a recent Instagram post of mine where I didn't give my son cow's milk, and that I did an extended breastfeeding protocol. Is there a reason why I did not provide cow's milk? And is it bad? So just to clarify, my son doesn't like cow's milk. Like he just doesn't like it. So I have to sort of hide it in a smoothie. I do think it's a good source of fat, of calcium. And so I'm not opposed to, and there's also lactoferrin in cow's milk, which has recently been shown even to improve intelligence in animal studies in mice, but it's been shown to improve intelligence in breastfed infants, because lactoferrin is much, much higher in breast milk than it is in cow's milk, but cow's milk does still have some lactoferrin. So that was the reason why my son doesn't drink cow's milk. He just doesn't like the taste of it at all. All right, another rapid fire question from Mako, which I just sort of answered. He says, I've been making your smoothies inspired by your old smoothie recipe. You've mentioned now that your smoothie is simpler. Can you discuss why you removed various items like spinach, rainbow chard, etc.? So for one, I've removed a lot of the fruits that spike my glucose levels more, like banana and apple. I find that blueberries have been shown time and time again, study after study coming out. In fact, just another one that came out in the past month, they improve cognition, they improve in elderly, in middle-aged adults, in children, just all age ranges. There's beneficial compounds in them that increase blood flow to the brain. So, and they don't raise my blood glucose levels very much. So, so I sort of stripped down the fruit to the berries only. I also will sometimes add other berries like raspberries and strawberries as well. I've really just stripped it down to kale for convenience, honestly. Raw spinach is, I don't find that I can get some of the same micronutrients from kale or chard. If I have chard around, I'll put it in my smoothie. But oftentimes I'm just quick putting it together. And so I just do the kale most of the time. But again, I do add the chard if I have it. And that's about it. So I do kale, I do avocado, blueberries, I do egg white protein powder for some more protein. Also, it blunts the glucose response. And I do hydrolyzed collagen powder. If you guys haven't read our topic page on that, please do. It's very comprehensive and very good. You can find that on the website on the topics tab in the navigation bar. All right, another rapid fire question was from Aof. He says, if 1,000 IUs of vitamin D3 raises blood levels by approximately 5 nanograms per milliliter, then why would you need to maintain 4,000 IUs as opposed to a lower dose of 800 IUs? So the reason for that is because if, let's say, someone has blood levels of vitamin D before they start supplementing based on just their lifestyle and combination of genetics, let's say they have 20 nanograms per milliliter. And so it would take, 4,000 IUs to get them up to 40 nanograms per milliliter. You need to continually take that dose, because if you were to only take 800, your whole lifestyle factors that at baseline had you at 20 nanograms per milliliter are going to stay constant. So a person, just because you get yourself to 40 nanograms per milliliter, if you then all of a sudden shift down to 800 IUs a day, eventually your blood levels are going to go back closer to your baseline levels because of the light exposure and all those things, et cetera. So that's the reason for that. Nikki asks, my question is about probiotics. I'm interested in using VizBiome sachets, but they're over my budget. Would it be effective if I only used one sachet per week instead of daily? So just as a note, that's pretty much what I do. I only use one. I don't have gut issues like IBD or colitis or things that require me to constantly take VizBiome sachets every day. There are individuals with severe gut issues where they are required to take in, or they've noticed that it tremendously helps if they take in the VizBiome daily. And of course, there's been randomized controlled trials showing this. Specifically with the formulation that is found in VizBiome, which was formerly known as VSL number 3. So because there is such a very concentrated dose, there's 450 billion live bacteria in the VizBiome sachets. I only take it like once a week. Jay says, in a recent episode with Kevin Rose, he had the founder of Pendulum discussing their unique probiotic for improving blood glucose regulation and type 2 diabetes. I'm curious if you've looked into it and what your impression is. So I will say that, just take this with a grain of salt. So Kevin is a friend of mine. We chat like pretty much on a weekly basis. And he had been telling me about his experiments with Pendulum. I haven't listened to the podcast yet, but I'm aware of how it's positively affected his blood glucose levels. I have another friend who's also male that is also in our friend circle and had the same effects. In other words, he was taking Pendulum, and after about 2 weeks of taking it daily, he noticed a benefit on his blood glucose regulation. So I decided to try it out myself. I ordered it and had the complete opposite effect. My blood glucose regulation not only didn't improve, it was much worse. So particularly my postprandial blood glucose regulation, where the same foods that I was eating were elevating my blood glucose levels 10 to 20 units, in some case higher. I mean, it was really bad. I continued the experiment almost to finishing the bottle, but it was just so bad that I stopped taking it. When I stopped taking it, my blood glucose levels returned back to their normal regulation. It was an N of 1. I have no idea. Perhaps there was some other factor that's unaccounted for. I should repeat the experiment because to see, if it really was the probiotic. But I had such a bad experience where it was so bad. I hated seeing my blood glucose levels like so high that it's hard for me to convince myself to repeat it. I may or may not do that, but for now, I'm just not taking that probiotic. Who knows? We're really just scratching the surface on understanding the effects of the microbiome on general health, on blood glucose regulation, on immune system and cognition as well. And so, there's probably all sorts of individualized responses there. And so it's really hard to say that you could just take a probiotic and everyone's going to have the same response. I mean, that goes for anything too, food as well. Scott asked what my thoughts are on using a HEPA air filter in my house. My thoughts are, well, I have 3 of them in my house, so I obviously like them. And I think that's pretty much it for this episode. Michael's asking in the live chat, have you heard of the company Viome that tests your gut microbiome and gives you feedback on your results? Yes, I discussed this in last month's crowdcasts. I do think that Viome and the American Gut Project are both 2 companies that seem to do a good job in terms of measuring the species in your gut microbiome. The species of bacteria in your gut. However, I have seen now several reports of Viome where they are giving recommendations and dietary and supplement recommendations. And I will say that those are not always grounded in science, and they're oftentimes a very general statement that I don't find to be accurate. So I do think that the results of Viome are putting the cart before the horse, basically. So I would proceed with caution on the recommendations given based on the species of bacteria found in the gut. I see Rachel Swanson asking about day 2 microbiome analysis, having pretty strong claims about lowering HbA1c. I'm not sure. I'm not familiar with day 2 microbiome analysis. Is that a company? Sorry, I can't answer that question. Galate is asking about fortified iron in baby foods like oatmeal. I think there's a difference between food that's fortified with iron versus supplemental iron. Supplemental iron that needs to be done with a physician's guidance, because supplemental iron bacteria use iron as well, and there's been some evidence that supplemental iron can cause can exacerbate a bacterial infection. So food that's been fortified with iron doesn't have that same effect, and so it can be a source of iron in the children, in infants, or toddlers' diet. When I was introducing complementary foods, I did ground up chicken and salmon, so that those were good sources of iron for my son. And Justin's asking about chewing xylitol gum having any effect on the gut microbiome. I've answered this question in a previous crowdcast. I don't remember which one, but it's been within the last 5 months. And there did not seem to be any detrimental effect on chewing xylitol gum on the gut microbiome. So any more of these rapid fire questions here that you are that you're putting in the chat, submit them there. You can sign up for the next Q&A. We'll be giving out the password soon when we send out this summary of this crowdcast with our email. And please submit your questions. The earlier, the better. We really like to take our time. As you saw with the green coffee bean extract, there's a lot of detail in some of these questions, whereas others, I don't need as much time. But I always enjoy these crowdcasts. Thank you so much for submitting such great questions and for pushing me to learn new things as well. And I look forward to next month's crowdcast as well. And Austin, this is not my house. This is my office. But thanks for telling me I need to clean it. It's kind of, it's actually been cleaned. So you must have a higher standard than me. I'll talk to you guys next month. Thanks so much.